Good morning, this is our team Jarvis. So our team members are Shubhavya K 19IT090 and Sivaranjani S 19IT096. So the topic which we have chosen is Li-Fi IoT at the speed of light.
The future demand for wireless communication networks within buildings and outside will further increase. The optical light communication called light fidelity (Li-Fi) using LED-based light sources as data transmitters offers an alternative to existing technologies such as Wi-Fi and LTE. Communication by light in the form of beacons has already been used since 800 BC, reaching its climax in 280 BC with the legendary Alexandria lighthouse. Around 400 BC, Greeks used polished shields, so-called heliographs, to transmit signals during armed conflicts. Over 2000 years later, in 1880, Alexander Graham Bell and Charles Sumner Tainter developed the photophone, a telephone that used light to transmit speech. In 2005, research into optical wireless communication (OWC) began at the University of Paris-Saclay and is reaching market readiness today.
The annual growth of light fidelity market is estimated to be 80% up to 2023 and the sales volume worth $0.5 billion in 2016 could explode to $75 billion in 2023. The term Li-Fi was coined by Professor Harald Haas, a German researcher at the Universities of Bremen and Edinburgh during a presentation at the 2011 TED Global Talk Conference, and this stands for Visible Light Communication (VLC). Li-Fi can deliver speeds up to 200 times faster than Wi-Fi, theoretically more than 200 Gbps. Li-Fi has several advantages like it's faster than the traditional network access, no electromagnetic interference, very precise GPS capabilities, it's eco-friendly, improved indoor connectivity, medical, aeronautical and defense, increased security, no health risks, very economical without any license, works well in places where radio frequencies are not permitted or may cause interference with other machines like schools, hospitals, aircrafts, industrial plants, etc.
In July 2019, the start of a 3-year project called Enhancing Lighting for the Internet of Things (LAOT) was announced. The aim of the project is the development of mass-market IoT applications based on Li-Fi. As a project partner, Fraunhofer Focus will ensure the integration of Li-Fi into 5G networks. LAOT originates from the EU Innovation Programme Horizon 2020 and receives €6 million in funding from the Public-Private Partnerships Photonics 21. In addition to Fraunhofer Focus, its Heinrich Hertz Institute (HHI) plus Signify, formerly known as Philips Lighting, Nokia, MaxLiner, Deutsche Telekom, KPN, Weidmuller Lightby, the University of Oxford, and Eindhoven University of Technology are participating in LAOT. The main objectives of the project are to provide an open reference architecture for the support of the Internet of Things and to contribute to the standardization of applications based on communication by light. For this purpose, Li-Fi must meet the ever-increasing demands on existing communication networks in terms of data rates, stability, and latency. With LAOT, we have established a powerful consortium of companies and organizations from the European lighting and communications industries. LAOT forms a closed value chain with partners representing the components, chipsets, systems, and application sector and research institutes working together for the commercialization of Li-Fi for the future IoT, says Volker Jegnickel, head of the Metro Access and In-house Systems Group at Fraunhofer HHI, who serves as project coordinator for LAOT. Professor Jean-Paul Liniot, co-initiator of LAOT and also leader of Signify's research in Li-Fi, confirms the potential of LAOT. Li-Fi can deliver high-speed communication interference-free with high reliability. The available spectrum can be fully reused in every room. The lighting infrastructure is in an excellent position to provide wireless connectivity for the rapidly increasing number of wireless devices in every room.
Li-Fi addresses a large variety of applications in the fields of live streaming, hospitals, workplaces, manufacturing facilities, schools, retail, and many more. If, for example, it's employed in aerospace, Li-Fi has the potential to transform both the overall passenger experience and enhance in-flight connectivity. Transmitting data through illuminations is attracting the interest of a number of airline companies. Li-Fi is faster and less expensive than Wi-Fi. It could transform the whole passenger experience. At the June 2019 International Paris Air Show in Le Bourget, Air France and Ubisoft demonstrated Li-Fi technology in an in-flight video game tournament showcasing this technology. According to the experts, the use of Li-Fi on board would save the equivalent of 10 to 20 people in weight per aircraft. Optical fibers are 1,000 times lighter than copper, said Serge Berenger, Senior VP of Innovation at Latin Core. Li-Fi will allow airline companies to do away with data communication boxes beneath the seats, each of which weigh a kilogram. Li-Fi connection speeds are more than 200 times faster than that of Wi-Fi and could mean quicker bank transactions on board planes. At the moment, airlines have to wait until a plane lands before in-flight transactions can be approved, explains Michael Prufel, an engineer with mobile telecoms company Orange. But in the future, flight attendants will be able to approve in-flight payments immediately thanks to the installation of Li-Fi in the cabin. As well as offering new applications for passengers, Li-Fi will also bring benefits for pilots because it is safer than Wi-Fi and does not pose any risk of electromagnetic interference.